5a, parts of a fraction. So yes, I'm bringing in the mathematical F word, fraction. So today we're going to start into that, and I know many times fractions are scary to students because they just never seem to mesh. Well, let's start out with the realization that a fraction really isn't that complicated. It's really just a ratio. A ratio is just a comparison of two values. If you're looking at two different people playing a sport, you may be able to see that the one person scores 8 points for every 3 points that the other person scores. Well, that's a ratio, but how we put it again is we say that it's 8 to 3. 8 to 3. For every 8 points that this person scores, the other person scores 3 points. It can be shown in a number of ways. 8 to 3. We could do 8 with a colon in between. 8 to 3. If you look back at the back of a lottery ticket, they'll show the ratio 1 to however many million for the probability of winning. Okay, so 8 to 3. 8 over 3, 8 to 3. And sometimes you'll even see it as an ordered pair, 8 to 3. Which really, if you start thinking of rise over run and slopes, that's really a ratio, isn't it? This much change in height for this much change in horizontal distance. This is going to be one of our major focuses, is this 8 over 3, because, boy, that looks a lot like a fraction. And that's really what it is. A fraction is just a comparison of two values. It's just a ratio. We use ratios all the time. I have a brick house, and with an old brick house as I have to mix mortar so that I can fix parts where the bricks are starting to come loose. I have to mix a special mortar. So I have this many parts of Portland cement for this many parts of lime for this many parts of sand. And that makes my mix. And it's just a ratio. This many of these to this many of these to this many of these. If you have to mix gas and oil to run a 2-cycle engine, same thing. This many parts gasoline to this many parts oil, 40 to 1. 40 parts gasoline, 1 part oil. It's just a ratio, a comparison. Now what is important is the order of those. If I'm looking at 40 to 1, 40 to 1 gasoline to oil, that's very different than 1 to 40 oil and gasoline to oil. Oops! Here we're running gasoline, that's our fuel, and we've got some oil for lubrication. Here we're burning oil and we got some gasoline that might possibly ignite at some point. So huge difference between that. So just keep that in mind, that the order is important. The same thing happens here when we're doing fractions. The order is important. Let's talking about a ratio. Well, what about a rate? A rate is a ratio where there are different units. So, like I said with the 40 to 1, that really, it's the same units. We're talking about gasoline to oil, but we're still talking 40 pints of gasoline to 1 pint of oil. 40 ounces of gasoline to 1 ounce of oil, right? It's still the same unit, our measurement. Whereas if I talk about 55 to 1, the ratio 55 to 1, I could say that's 55 miles to 1 hour. That's a rate. That's your rate of speed, right? How many miles you cover in 1 hour. So a rate compares two values that have different units. 55 miles per hour. 32 feet per second. So that's where our differences come in. Or even look at a recipe. This many cups of flour, this many teaspoons of salt. So we have different units. And that's a rate. By continuing on with that, let's now get to fractions. Well, if I have a rate 3 to 5, well, that's a fraction. We have a numerator and a denominator. Numerator is the top, denominator is the bottom. So it's just breaking that into pieces. And a fraction is really just setting yourself with a base amount. This is saying if you have a whole thing, let's say I have this whole rectangle, the denominator tells me how many pieces of equal size we're going to break this rectangle into. 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5 pieces. So 5 pieces will make a whole rectangle. It's kind of like if you take a pizza and they say, how do you want it cut? I'll cut it into 8 pieces. Assume their cutting's a little better than mine, right? Well, you cut it into 8 pieces, and all that's doing is telling you how many pieces there are in a whole pizza. But now when we look at these, I say, okay, well, there's 5 in a whole. So this would be with a pizza, we'd have something over 8. The denominator would be 8. There's 8 pieces make up whole. So anytime you're looking at a fraction, that denominator says how many pieces or segments do you need to get one whole item. So we need 5. The numerator tells us how many pieces we have. So in this case, our numerator, we have 3. We have 3 out of 5. 3/5. How many pieces to make a whole one? How many pieces we actually have. So if I'm looking at this, what if I say we have 2/8 of a pizza? Well, that means the pizza was cut into 8 pieces, and we have 2 out of those 8 pizzas. So fractions aren't really that bad. It's giving you a base to look at, the denominator, how many pieces make up a whole one. And it tells you how many pieces you have. Well, what if we went a little crazy with this and said, "13/5." Well, what does that tell us? Well, that tells us that we have that 5 pieces will make up a whole one. And we have 13 pieces. So what I'm going to do is I'm going to So I'm going to start filling them in. So there's 5, 1, 2, 3, 4, 5. Well, I've got 13, that's only 5 of them. Six, 7, 8, 9, 10. Well, I need more. 10, 11, 12, 13. 13 fifths. 5 make up a whole. And I have a total of 13, so I have 1 whole one. I have 2 whole ones. And then I have 3 fifths of another one. That's 2 and 3 fifths. I have 2 whole rectangles and 3 fifths of another rectangle. See, ratios aren't as painful as you think. In fact, when we get into operations on fractions, you're really going to find that multiplication division of fractions is actually easier than addition and subtraction of fractions. Okay? So these things that we need to look at. Well, let's compare some fractions. Okay, let me just grab something that dropped here. Okay, well first let's look at equivalent fractions. Let's switch to a different color, my glue's being a little finicky on me here. Okay. Equivalent fractions. When two fractions are equivalent, that means they're showing the same ratio. They may use different numbers to do it, but they're still showing the same ratio. Well, what do I mean by that? Well, let's look at a few different fractions here. So let's say we have 3/4. We have 6/8, and we have 11/16. Okay, so I've got 3 fractions here. I want to see whether these are equivalent or if they're representing different proportions. Well, 3/4, well, how do we do that? We can remember that 4 tells us how many pieces there are in the whole. So I'm just going to break this box into 4 pieces, and we've got 3/4 of them. So that's 1, 2, 3. 3/4. Well, let's look at 6/8. So I broke that box up into 8 pieces. If I've got 6 of them full, that's 1, 2, 3, 4, 5, 6. And why did I color that here instead of going down to the next one? Well, if you see the way I color it, we can see that 6/8 fills in the same amount of area as 3/4 did. Well, what about 11/16? Okay, 11/16. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, again, I colored it in such a way that I can see that 11/16 is not equivalent to 3/4 or 6/8. See, we would need one more piece. 12/16 would be equivalent. But that's equivalency. It's just, are those fractions representing the same ratio, even if they're not using the same numbers? And 3/4 and 6/8 are. So I can say those are equivalent fractions, or I can say that 3/4 is equal to 6/8. 11/16 is not the same. So I'm just going to leave it by itself over there. It was not the same. But that's equivalent fractions. See, so far this isn't so bad. Not as painful as you might have remembered. Well, what about comparing fractions? Well, while we have this, comparing fractions, remember comparing things less than, greater than, equal to. Well, let's take a look at this. Well, we already determined that those fractions are equivalent, so they're equal. Well, what about this? What about comparing 6/8 to 11/16? Well, we see that 6/8 filled out this much, 11/16 filled out this much. It didn't quite fill out the whole thing, so 6/8 must be greater than 11/16. So it allows us to do a comparison. Now, a couple things with comparing fractions that I'd like to point out that will help us. Well, first of all, you can do a visual like this, build it and see what the comparison is. You may be able to put it to see if there are equivalent fractions or get them to another equivalent fraction that allows us to do a comparison. But some things that I'd like to point out to you are these. Okay, if I have 1/1, 1/2, 1/3, 1/4, 1/5, get this out of the way, and I'm just going to put triple dot, that ellipsis saying it keeps on going. When you have 1 over something, so one piece of something, as the number in the bottom gets larger, one piece of it gets smaller. Think about it as if you've got a cake and you cut that cake into 4 pieces, everybody gets a quarter of the cake. If you cut it into 5 pieces, now the pieces have to be smaller for you to split that cake between 5 people. Cutting it into 6 pieces, the pieces get smaller. 7 pieces, even smaller. 8 pieces, smaller, right? Or if you and a group of friends as kids were out there shoveling somebody's driveway for money, and they gave you 20 bucks, well, if it was you and your buddy that were doing it, you got 10 bucks each. If there were 4 of you doing it, you only got $5 each. If there were 5 of you doing it, you only got $4 each. If there were 10 of you, you got $2 each, right? So the more pieces you have to break it up into, the smaller each piece is going to be. So when we're comparing one piece of a number of pieces here, the larger the denominator, the smaller that piece is going to be. So 1/5 is going to be less than 1/4. When you're dealing with greater than and less than, remember, the smaller side points to the smaller number. The larger side points to the larger number. But you have to remember, it's not looking at the denominator and saying, oh, 5 is bigger than 4. We have to look at it as we only have one piece out of 5 to make a whole one. There's 5 pieces needed to make a whole one. I only have one of them, so I'm splitting it into smaller pieces. I have one of those smaller pieces. So 1/4 is smaller than 1/3. 1/3 is smaller than 1/2. And obviously 1/2 is smaller than 1/1. If we only break it into one piece, you get a bigger amount. So a comparison there if you're dealing with 1 over a number. It gets a little more complicated when you start taking multiple pieces of it. Let's say we compare 4/5 and 3/4. Well, now we've got 3 pieces. We know that 1/5 is going to be less than 1/4, but we've got 4 of those fifths and we got 3 of those fourths. So what we could do is we could do a visual, and I'm going to do it vertically now just because it will allow a better visual comparison, but I'm breaking 4/5, that's being broken into 5 parts. 1, 2, 3, 4, 5. And then 3/4 is being broken into 4 parts. 2, 4, so we can see our parts here. So I've got 4/5, so that's 1, 2, 3, 4. And I've got 3/4, 1, 2, 3. Just for comparison's sake, we see that 3/4 doesn't fill up as much space in our original rectangle as 4/5 does. So 4/5 is greater than 3/4. Now there are other ways that we can do comparisons with these, and I'll show those to you in another video. But just as one possibility, if you're careful about your drawing of it, you can make this work. But I'm going to show you something along the lines of what I did here, and these things come in really handy because a lot of times you run into these things where it's a relatively straightforward comparison if you know some basics. So here we said 1 was greater than 1/2, was greater than 1/3, greater than 1/4, greater than 1/5, etc., etc., etc. I'm going to do the opposite here, and I'm going to go, actually I wouldn't say opposite, I shouldn't say opposite, I'm going to do comparison of 1 shy of the whole thing. So if I have 0/1, once is not a real word, 1/2, 2/3, 3/4, 4/5, 5/6, etc., etc., etc. So now what I'm doing is, instead of giving you one of them, I'm just coming up 1 shy of having all the pieces. I have 0 out of 1, 1 out of 2, 2 out of 3, 3 out of 4, right? If I add one more piece to each of them, I get the whole. If I add one piece to this, now I've got 1, 1, or 1. If I add one piece to this, I've got 2 over 2, or 1. If I add 1 piece to this, I've got 3 pieces over 3, or 1, right? So I'm just shy of it. I've taken one away. Well, if we remember that the larger the denominator, the smaller each piece was, then we should also be able to recognize that the larger the denominator, the smaller the missing the piece is, so the greater portion of the whole that we're going to have. So 5/6 is only 1/6 away, 4/5 is 1/5 away, so 5/6 is greater than 4/5 is greater than 3/4 is greater than 2/3 is greater than 1/2 is greater than, obviously greater than 0, right? So that's another basic comparison that we can get used to, and you can just recognize, oh, well, which is larger? 7/8 or 13/14? Ah, well, this is 1 shy of that, so I'm only missing 1 piece. I'm only missing 1 piece. Since 14 is bigger than 8, my pieces are smaller. Therefore, that one missing piece is going to be less than the one missing piece here. Therefore, the 13 that I have is going to be greater than the 7 that I have there. So that's yet another way which we can do that comparison. So there are these little things that, as we get used to them, they can make our life a little bit easier as we're doing comparisons. I just want to grab this thing and keep falling down here. You get to experience the full excitement of what happens during a live lecture. Things fall, things get lost. Okay, so that's comparison. So now let's talk about proper fractions, improper fractions, and mixed numbers. So a proper fraction if something's proper, it means it's correct, right? It's done in a way that is generally accepted. How about that? If someone's proper, they do everything as they're supposed to do it, right? So if you have a proper fraction, a fraction in the form a over b, a is less than b. So anytime you have a fraction where the numerator is smaller than the denominator, you have a proper fraction. And that's what I've shown you in most of our examples. The only time I didn't have one was when I showed that one where we were able to break it into 3 boxes and work from there. So that's a proper fraction. An improper fraction fraction a over b is where a is greater than b. So an improper fraction is a fraction where you have a numerator greater than a denominator. An improper fraction, because that means you have more pieces than what's necessary to make a whole. For the proper fraction, that thing just does not want to agree with me today. So proper fraction, an example would be 2/5. An improper fraction, 9/5. Right? 2 pieces of the 5 that make a whole, meaning that this is less than a whole thing. 9/5, well, only 5 pieces are necessary to make a whole one, so we have more than one whole one here. Right? That's an improper fraction. The other thing we deal with is a mixed number. A mixed number is one that can be written in the form a b over c. So a b over c, where a is the whole part and b over c is the fractional part. And when you have a mixed number, b is going to be less than c, and a is just going to represent the whole part, such as 1 and 4/5. So proper fraction, the numerator is smaller than the denominator. Improper fraction, the numerator is greater than the denominator. Mixed number, you have a whole part and a fractional part, where the fractional part, the numerator, is smaller than the denominator. Now we may notice with this that 9/5 is the same as 1 and 4/5. So there's a lot of things we can do with that. Hopefully my final time picking this up. I apologize for that. So when we have an improper fraction, when we have a mixed number, those two can be swapped back and forth. And we're going to go through how to do that. Proper fractions are proper fractions. You can't really swap them back and forth between anything because there's only part of the whole. But what if I want to take an improper fraction and turn it into a mixed number? So improper converted to a mixed number. So improper fraction to a mixed number, 11/4. Well, what can I do? Well, the easiest thing to do here, I mean, yes, I can do the picture because we really did that already. We did that when I had the improper fraction previously, and I said, oh, well, we can take this many of these, make the first one. Oh, we still have more. This many make a second one. Oh, we still have more. This many make a third one. I think it was 13/5 I used. But the easiest way to do this is to just divide. Say, how many times does 4 go into 11? Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So it goes in twice. That becomes my whole part. 2 times 4 is 8. Okay, so 2 times 4 is 8. 11 minus 8 is 3, so we have 3 left over, 3/4. Whoa, Mr. Dick goes to the, whoa, slow down. Say what? Fractions are just division, aren't they? 11 divided by 4. 11 divided by 4. 4 goes into 11 how many times? Twice. 2 times 4 is 8. Subtract, we get 3. Now, with the subtracting, with the division that we've done before, we either say that's a remainder of 3, right? Or we continue on and turn it to the decimal. We're dealing with fractions here, so we've got a remainder of 3. Well, this remainder is what's waiting to be divided by 4. So we have 2 with 3 divided by 4, or 2 3/4. So what did I say when I was going through this initially? I said, okay, how many times does 4 go into 11? It goes in twice. 2 times 4 is 8. 11 minus 8 is 3. And I put it over 4. Well, look what we did here. How many times does 4 go into 11? Twice. 2 times 4 is 8. 11 minus 8 is 3. Remainder of 3, or 3 waiting to be divided by 4. So when I'm converting from an improper fraction to a mixed number, I'm really just speaking through or thinking through long division. So it's weird when you hear it, you're like, wait a second, where is that coming from? How are you getting this? What does that mean? Why is that there? That's all we're doing. So let's try another one. 62 fifths. It's an improper fraction. The numerator is greater than the denominator. So I want to know how many times does 5 go into 62? Remember, if I were dividing 62 divided by 5, how many times does 5 go into 62? I can look at this and go, oh, 5 goes into 6 once. 1 times 5 is 5. Subtract, I get 1, bring down the 2. How many times does 5 go into 12? Twice. 2 times 5 is 10. Subtract, I get 2. Gives me a remainder of 2, which will be divided by 5. So I get 12 2/5. So going through here, I go, how many times does 5 go into 62? I happen to know that 5 times 12 is 60, so it goes in 12 times. 12 times 5 is 60. Well, 62 minus 60 is 2. So if you've heard people doing this and they go, oh, how many times does 5 go into 62? Okay, it goes in 12 times. 12 times 5 is 60. 62 minus 60 is 2, and they get 2/5, and you go, what did you do? That's all they did. They did long division. So there's absolutely nothing wrong with you going through and doing the long division. That's okay. That's allowed. Once you get practiced with it and you know how to do this long division, that's where you start doing it and you start talking through the long division as you do it, but just with a improper fraction getting switched to a mixed number without having to write out all the division. So that's converting from an improper fraction to a mixed number. Well, what if we start with a mixed number and we want to go to an improper fraction? Well, this is actually the reverse of that process, and it's actually easier. 3 2/7. Remember what the denominator tells us. It tells us how many pieces it takes to make a whole one. We cut a pizza into 8 pieces, then over 8. However many pieces there are, over 8 tells us how many whole ones we have. So when we're looking at this, there are 7 pieces in each whole item, whatever it happens to be. We have 3 whole items. So 3 of them, each of them having 7 pieces, gives me 21 pieces. 3 items, each of them broken up into 7 pieces, gives me 21 pieces. 3 times 7, 21. And then we've got 2 more pieces, 23. 7 still representing how many make a whole, whatever the item is. So to convert from a mixed number to an improper fraction, we take the whole part and multiply it by the denominator and add the numerator. 6 4/9. 6 times 9 is 54, plus 4 is 58. 58/9. 1 3/4. 1 times 4 is 4, plus 3 is 7, 7/4. And that's it. That's converting mixed numbers to improper fractions. So we've got an intro of what are fractions really. They're just the denominator telling us how many pieces it takes to make a whole of something, and the numerator telling us how many pieces we have. And then getting into mixed numbers and improper fractions. Improper fractions is just where we keep it in that form of we have this many pieces, each grouping of 7 of which will give us a whole one, versus a mixed number where it says, okay, rather than telling us just how many pieces it has, how many whole ones do we have and how many leftover pieces do we have? The mixed number, a whole part and a fractional part.